Hello, in today's tutorial we are going to install Linux Arch. Linux Arch is a rolling distribution, so that means there are no major upgrades like Ubuntu 14 to Ubuntu 16 and stuff like that. You always are on the last version. What's also really nice about Arch is that the repositories and documentations are very well maintained. So whenever you need to look up something, you will usually find a good explanation and a lot of details. The forums are active, IRC and stuff is active. And you always have very up-to-date packages and a huge user repository. Also, the packet manager, which is Pacman, is quite nice and gives you a lot of support. And there is also PacAUR, which is a sort of little add-on on top of Pacman, which allows you to install stuff directly from the user repositories. So we are going to install it, and then on top we are going to use i3, which is a tiling window manager. You can see at the bottom I am using Polybar, which allows us to customize how exactly we want to have it look like. We are going to use Pickham, which is a composition manager, which allows you to do transitions like slowly opening up windows, setting opacity for certain windows. We will also be installing my ZSH, which is this nice little project. It uses the ZSH shell and gives you some nice add-ons like showing you the branch you are in if you are inside a Git folder and stuff like that. Also shows you the execution time of commands. So if you run something, it will automatically time how long it takes and also print you a time of when the command was executed, which I really, really like. What we can also do is stuff like using Rofi, which is a menu launcher. So you use a keyboard shortcut, open this, and then you just type the application name you want to start and click on enter, and that will then in turn start the application. We are not only going to install it, but we are also installing it by using a encrypted device. We will be using systemd as our boot manager, and we will be using logical volume groups, which allow us to more easily change partition sizes or add a physical disk in later on, and then increase a certain partition you already set up. In this video, I'm going to do an example inside a virtual machine. So I am first going to start my Word Manager, and I'll be using kernel-based virtual machines for this demonstration. If you start your installation, you most likely want to start downloading an image. Let me quickly mount a container that contains my images. So when you download your file, you usually also can download a signature file. And then you can stuff like pacman key to test if your image is legit. So it's basically creating a checksum of your image to compare that to what we have in the system. So that will be signed by a PGP signature, and that way we can make sure that we actually downloaded the image we wanted and not got something that was tampered by during the download. If you are not running a distribution with Pacman, you can use GPG, specify the key server options, and just specify the file. So that is a way how you can do it without having pacman if you're basically creating or downloading your image on an Ubuntu or something else. I think it even should work on Linux, on Windows, because there are GPG versions for that too. Okay, so then if you have your image and you want to install a computer, you usually want to use an USB stick and then do something like use DD. You will need root permissions to write to a disk, and then, for example, install it to def SDB. And one parameter I usually specify is a block size of 4 megabytes. That will vastly improve the transfer speed of copying it to your disk. We don't need that here because we are all doing it in a virtual machine. Let me just quickly kill Pick'em so I am not getting any transparent background, so it's easier for you guys to read. So we are now going to select a media, and we are going to pick the last Arch Linux version. I downloaded one yesterday. So today, or the day before yesterday, they basically built a daily version which you can download that then has the last state of the software. You do not need a lot of RAM. I have like plenty in here, so I'm going to give it 8 gigs of RAM and 8 cores, so the installation should go fast. Then I need to specify a place where I'm going to save my image. I'm going to create a new storage volume called Arch Linux with 20 gigabytes in size, which is more than enough. And we are going to install onto this QCow image. I also want to use uefi, so I need to customize my configuration before installation. As far as I know, this is the only step where you can do that. You will need to have the right OVMF image installed. You can find that on GitHub and many places. The Vim manager seems to have a bug, so if I select that and click apply, it just changes it back. But if you click on start installation while having that selected, that usually works. It's now going to create the virtual machine and start it up, and we can close our Vim manager and have to change over quickly because we do not want to start a uefi shell. We want to boot from the actual Arch Linux ISO. I'll make it a little bit easier and go into full screen mode so we do not have any distracting borders. So let's start by booting off the ISO. So that is now not starting off the virtual disk, but of the ISO, which is mapped as a virtual disk, so like a CD-ROM drive. And it will start based off that ISO and log in as root. The first step I want to do is to load my keyboard because I have a German keyboard, and that would just mix up all the characters. So that is done. Then the next step would be to verify that we loaded successfully with the EFI. So we simply look inside the firmware folder and there is a EFI folder. And if we are in EFI mode, we can basically list the contents of E5 vars. And that once you have contents in here, you know it worked. Then after that, we of course need a network connectivity. I'm using the KVM and we are getting an IP address by DHCP. That is done automatically. If you do not get one, just type DHCP CD or DH client and then F0 or whatever the name of your interface is. Mine would be ENP1S0. And that would then send out a request to your DHCP server and ask for an IP address. Then we would check if we can route to the internet. And if that works, we just need to make sure that we also have a DNS server set. And then we are able to resolve DNS too. Okay, so that works. And now we want to make sure that we also have the correct time set. So if you use any sort of encryption, you usually need a proper time set. And that is why we are setting the NTP to true. Then we would start creating or preparing our virtual disk. So we have one virtual disk called dev VDA with a size of 20 gigs. And we are going to use fdisk to start partitioning that up. So since I want to use the uefi stuff, I need a GPT partition table. And we simply do that by pressing G and hitting enter. That will create a GPT partition table and give it a disk label. And now we have to split up the disk. So usually you want to split it up into at least 2 partitions. So you need a root partition and a swap partition. But we are also going to encrypt basically all of our partitions. That doesn't work properly for the boot partition. Basically, you cannot use the BIOS stuff on a encrypted device. So you usually create a separate device for that. And that is where we are going to start. So we are going to create a really small partition. First sector, we are going to accept the default. And we are giving it a size of plus 256 M. That means we get a 265 megabyte partition. And since this is going to be a EFI partition, I am going to also specify a type of 1, which is the EFI system type. So now you would probably say you can now create 2 further partitions for swap and for root, but we want to encrypt the remainder. So we are going to create just 1 more partition, and then we are going to encrypt that partition, and then we will set up logical volume groups on top of that encrypted partition. So everything, our swap, our root system, or whatever volume groups we want to create are all encrypted. Okay, so we now need to create a second partition, and we are simply going to accept all the defaults. And also the type of Linux file system is fine here. And then all that's left to be done is to type W and press enter, and that will write the changes to the disk. Okay, so next step would be to then encrypt this second partition we just created. First, we check if dm-crypt is all loaded properly, and if we do not get any output or errors here, it's fine, and we can start with our crypt setup. You usually want to start by choosing a cipher. So different ciphers, think of it at different methods on how to create the secret keys. And they have different key lengths. So they have different attributes like different speeds for encryption, decryption, and some are faster, some are slower. So this basically tests a bunch of default ciphers with default key lengths and gives you the throughput. And one that has been working good for me is the AES-XTS. So I will be picking that one. So we are using the -C to create. And we'll be picking the XTS plain cipher. And we will specify a key for 512 bits. And then we say format that partition. And the partition is the second partition we set up, so dev VDA2. Now it asks us if we are sure that we want to do what we are doing, which is basically overwriting all the existing data. So if you previously had any data, this is the warning where you type, okay, I will delete everything that I have, and I am not able to restore that. So we are typing in yes, and now it's time to specify a password. You need to make sure that you remember this password. There are ways how you can use a second or third or fourth password slot and create additional passwords. So you have like a default way you can go back to a second password. But right now we only have, if you follow this example, you only set up one password, and you need to make sure that that password works, because without it, you will not be able to get back into your files. But that's the whole purpose of doing this. Okay, so now that we have formatted our disk, we can now basically open it. So we enter our password, and then we are able to decrypt it and access the data and start creating file systems and stuff on there. For that, we need to specify a name. I am going to call it LVM. Now we enter the password again that we used on the cryptsetup looks format command. And if you now list your dev mapper folder, you can see that a new device has been created, which is called LVM. And you can think of that like the encrypted device is dev VDA2, and then it creates this virtual mapper device in an unencrypted state. So once that is done, we can start create using the pv-create command and run the dev mapper LVM, and that will create our so-called physical volume. And on top of that, we need to create a volume group. So then we run vg-create. We are calling this volume group main, and it will use the LVM mapper device. Okay, so now we have this volume group inside which we can start adding logical volume. The first we are going to create is a 2 GB volume, and I will be using that for a swap. So we are going to give it the name swap, and it will be part of the main volume group. So we run that, and that creates a 2 GB partition inside our 20 GB partition. Then this next step depends on you. Some users prefer to have a separate home partition or a separate var or op partition. Since this is like a starter tutorial, I will be just creating one root partition, and I will be using all the remaining rest. So this time it's a lowercase l, and we will be using 100% of the free space. And we are going to give it the name root, because that will become our root file system. And it will also be part of the volume group main. Okay, so we basically now created our logical volume group sort of similar to partitions, and now we need to create a file system on top of these. So the first file system we are going to create is for our boot partition, and that one will not be encrypted, so we can just use the direct name, the VDA1. Then we need to create a file system for our root partition. I'll be picking ext4, give it a name root, and then we reference the logical volume name. So that will be dev mapper main root. And once that is done, we still have our swap partition. So we are going to use mkswap. And we are also going to use the volume group main swap. Okay, so we now have all the file systems and all the partitioning done, and we can start installing the base. So we will basically use the MNT folder, mount all the disks that we just created to this MNT folder, and then start installing Arch into this folder. So first I want to mount my root directory onto MNT. And then inside this root directory, we will need the boot folder, because then we can use the dev VDA1 and mount that to the boot folder inside the MNT partition. So when we then install our stuff into /MNT, it will basically install the base system onto the main root logical volume group, but the boot stuff will be on the unencrypted VGA1. Okay, so that is done, and we can now basically start installing the base system. For that, we use Fstab and specify the folder, MNT. We need the base and the base devil system. Sys-Linux, I usually also specify nano, because that is the easiest editor for most people. Then we are going to install the Linux and the Linux firmware packages. We need the mkey init cpio to generate the new kernel image stuff. Since we are using logical volume groups, we need the lvm2 package, dhcp-cd to make sure that we are getting IP addresses, inet utils, so it's easier to create network connections. And then depending on your architecture, whether you have Intel or AMD, you should install the Ucode, so Unicode packages, which will help us booting later on. I have a Intel CPU, so I'll be picking the Intel Ucode package. And that will basically download and install our base system, which has a total size of almost 1400 megabytes, so like 2 CDs in size, which is rather small compared to example, a Windows 10 installation, which has roughly 20 gigabytes. So it finished installing all the base packages, and now it's basically generating a new Linux kernel and a fallback version. In case something is wrong with the main version, you can always select the fallback and use that one. Okay, so that took 45 seconds altogether to basically install the base for Arch, and it's also a really small base. So we are using a total disk space of 1.9 gigabytes right now, which is not really a lot. Okay, so that is done. Let's run the sys-linux install update. And that will generate the base for our BIOS stuff. But we still need to modify that a little bit. Hold on, I need to go to the mnt boot syslinux and syslinux.cfg. And then I use Control W to search, and I'm going to search for append because we need to specify these startup definitions. So the first thing I want to do is to tell it to use a crypt device, which is located on dev VDA2 under the name main. And in there we are using the root directory, which is using the dev mapper main root. We have a read-write. My language is German, and my local is also German. And since we edited for the main version, we also have to do the same for the fallback. All right. So we now created that part, and now I would also have to make sure that the etc fstab file is defined. which basically tells the system where and how to mount all the different partitions that we have. So we can use the gen Fstab to do that. Oh, but I still want to create, I basically want to enable my swap first. So now we have a active swap of 2 GB and we have everything mounted in the way that we want it. And now we can use the gen Fstab command that basically looks at the current mounts and then generates a file based on that. So these are the default switches, like we want to use UUIDs, and then we can pipe the output into the Fstab file. So you can see I am using 2 of these arrows. That means append to the rest. If you only have 1, it would overwrite, but we simply want to append to the rest. And then we can take a look inside the file. And you can see the 3 different UUIDs and all the different mount points specified. So I am going to do one more change. Since I am using SSDs, I am going to specify no A time and discard. Those are basically settings that gives your SSD a longer lifetime, because by default you would mount them in a way that is not the best for having a long life. Yeah, let's do them in the same order. Okay, so now that has been prepared. And now we can start doing like the finishing touches inside the operating system. So for that, it's easiest to use the arch-ch-root. So now we are basically changing the root of our running operating system to be inside the MNT. So now that will be the path to the Fstab file we just created. So we do not need to add the /MNT at the beginning of all the commands now. So first I am going to hard code the language UTF-8 into the local.conf. Then I am going into the local.gen file. And in here is a list of all the locals that are supported. And you just need to find the ones that you want to use. So again, I am using the DE one for UTF-8. So just remove that comment over here, save the file. And then we can use the local gen command. And that will then regenerate all the locals that we uncommented. So if you need like more than one local, you can just uncomment multiple here. Now I also need to specify my key map. So I do not want to change my keyboard layout each time I start. So I am echoing that to the VTC console, and I am also going to set a font. And this time again, I am using the 2 arrows to append. Okay, after that is done, we also want to specify our time zone. And you can just use the continents or main countries. I am going to go through Europe and Berlin. And we simply soft link that to the local time file. Yes, then there is another thing called multi-architecture or multilib. Basically a way on how you can run both 64 and 32-bit applications inside the same operating systems. So you just open the etc pacman.conf, scroll down and uncomment the 2 multilib entries and run a simple pacman-sy. That will basically connect to the repo mirrors and then retrieve a file for everything that's in the multilib stuff. Okay, so we are basically done we did some changes to the sysconfig stuff, so we'll eventually also have to regenerate the kernel image. But first I want to do some further changes. So we go into the mkinit cpio.conf. And here for modules, I am going to load my ext4 module, and then we go down to the hooks. And in the hook section, let me see. I will definitely need the encrypt module. We are also going to use lvm2. File system is already present. Yeah, I think these are the only ones we actually need to load. So we can save it again. And I think the next step then would be to regenerate the kernel mkinit cpio-p for Linux. So that will now basically rebuild what we previously built, but this time include the modules that we need to start up. And again, it's doing it for the main and for the fallback. All right. I also need to set a password for the root so that I'll be able to log in. And yeah, we want to restart the system soon. So I'll also should make sure that DHCP CD is running and is enabled. So next time the system boots, it will automatically start up DHCP and get an IP address. I also want to specify a hostname. So we can just run the hostname control set hostname, and let's call it archtest, which then in turn should write to the etc host. Oh no, it doesn't. Okay, then let's go into the etc hostname and specify the hostname here, but without the domain. And then we are going to go into the hosts file to create a entry first for the local host. If you are using IP version 6, you do a second loop back for that. And then we do another host entry for archtest.local domain archtest. And as you can see, if we now ping the archtest, we get a response of the localhost because that's the first rule in our hosts file. We now specified archtest.local domain. You can, of course, also just set the first part. This is just how I do it here locally. So once that is done, we then have to start installing the bootload systemd stuff. So we are using boot control, and we specify the boot path and tell it to install. So that again writes a good set of defaults, but we still need to customize that a little bit further. So we are going to load up the loader.conf and remove that long shitty generic name and just call it arch. And then I am going into the bootloader entries folder. And here we are going to create an entry for our arch. Give it a title. So Arch Linux is the default. VM Linux minus Linux. Then we specified the initrd for the Intel U code. So if you have AMD and installed the AMD package, you will of course have to change it here too. And then we specify the path to our actual initial init ram fs minus linux.img. Then we also need to specify our device. For that, I usually exit out, because we first need to get the UUID. So you can type bulk ID, and we want the bulk ID of our main disk. So basically the disk that contains all the logic volume groups. In our example, that would be the VDA2. So we want the UUID string. So we could do something like and cut minus. So we use cut and we use the delimiter of that. And we want the second part. Yeah, so that is the UUID we want to extract. And we are simply going to append it to the loader's entries argconf. So if we then go back to our file, we now have this string that we needed, and I don't have to manually type it. So we now specify options, tell it that we are using a crypt device, and that the UUID equals this string. And on there, we use LVM as our physical volume. And on there, we use def mapper main root. And then we also specify quiet and that it's a read writable. Okay, so I guess we are pretty much done now. We can now save our files. I can now hit exit to exit out of the ch-rooted environment. Took us 10 minutes to configure the base, as you can see, like 9 minutes and 43 seconds. And now we can start unmounting the disks that we mounted. So first I want to unmount the boot mount and also the root directory. So yeah, so that would basically run 2 mounts commands to unmount the boot and to unmount the root. And once that is done, we can simply run the reboot. And if everything has been done properly now, we should be able to reboot and we should be welcomed by some EFI messages. Then it should hopefully ask us for the password for the disk encryption, then create the logical volumes that we set up, spin these up, and mount all of that as we defined that in the Fstab file. Okay, that is going to take a little bit too long for me. So let me speed that up, exit full screen, and forcefully restart the virtual machine. Okay, we can now see the Linux boot messages. That is a good sign that we are starting Arc. It's now asking us to enter the disk encryption. And we are up and running. So as you can see, we have our root partition, which is mounted to def mapper root. We have our swap, which is active. And if we take a look at the system usage, and with the base install, we are now using 85 megabytes of RAM. And we are using a total disk space of 1.9 gigabytes, which is rather small one. Okay, so that was basically part 1, which is installing the base system. We do not have a desktop yet, so that will be coming up in the next part. And then we are going to configure all the desktop elements like Polybar, Rofi, i3, and all that stuff. So see you soon.